are for our third keynote of this conference, titled Design Imperatives in Social and Environmental Crisis, which I am extremely honored to introduce. Social and environment crises are tightly coupled and entangled in design, computation, and data. These entanglements make their decoupling and one's ability to notice them and question them difficult. In this context, what is the connection between computation and ecological thinking? How would design education, ethics, practice, and projects shift if we prioritized using our intelligence, our creativity, and resources to care for our people, our places, and our planet? I can't think of four more appropriate figures to help us navigate these entangled questions more than our presenters today. Paolo Antonelli is Senior Curator at the Museum of Modern Art in the Department of Architecture and Design, and MOMA's Founding Director of Research and Development. Her most recent exhibition, Broken Nature, opened at MOMA in November 2020. She's also currently working on Design Emergency, an Instagram and book project that explores design's role in building a better future for all, in collaboration with critic Alice Ralston. Lydia Kallipoliti is an architect, engineer, and scholar whose research focuses on the intersection of architecture, technology, and environmental politics. She's an assistant professor at the Cooper Union in New York. Kallipoliti is the author of The Architecture of Closed Worlds, or What is the Power of Shift? The History of Ecological Design for Oxford English Encyclopedia of Environmental Science, and the editor of Echo Redux, an issue of architectural design in 2010. She is the principal of ANAcycle think tank, which has been named a leading innovator in sustainable design in Build's 2019 and 2020 awards, and head co-curator of the 2022 Tallinn Architecture Biennale. Thirdly, we have Justin Garrett Moore, a program officer for the Humanities in Place program at the Andrew W. Mellon Foundation. His work focuses on advancing equity, inclusion, and social justice through place-based initiatives and programs, built environments, cultural heritage projects, and commemorative spaces. He has extensive experience in architecture, planning, and design, from urban systems, policies, and building projects to grassroots and community-focused planning, design, and arts initiatives. With over 15 years of public service in the city of New York, he has led several urban design and planning projects. From 2016 to 2020, Justin was the executive director of the New York City Public Design Commission, and in 2021, received the American Academy of Arts and Letters Award in Architecture and was named to the United States Commission of Fine Arts by President Joseph Biden. And lastly, we have Mariana Popescu, an assistant professor of parametric structural design and digital fabrication at the Faculty of Engineering and Geosciences at Delft University of Technology. Mariana is a computational architect and structural designer with a strong interest in innovative ways of approaching the fabrication process and use of materials in construction. Her area of expertise is computational and parametric design, with a focus on digital fabrication and sustainable design. Her extensive involvement in projects related to promoting sustainability has led to a multilateral development of skills, which combine the fields of architecture, engineering, computational design, and digital fabrication. In 2019, Mariana successfully defended her PhD, which was nominated for the ETH Medal for Outstanding Dissertation and was named a pioneer on the MIT Technology Review Global List of 35 innovators under 35. Now, presentations and responses by our guests will be followed by a conversation. And with that, it is my great pleasure to welcome to this great keynote session, all our presenters, and Dr. Lydia Kallipoliti. Welcome to ACADIA.
So I guess I'm going to start directly. Lydia, you're going to say a few words. I'm going to just dive into it. My role today in this great panel is to kind of set the tone, even though I am somebody that has been able to appreciate how much computation has done for ecological thinking and for design. So are you seeing my computer already? I hope you are. Let me see, because sometimes it's hard. Can somebody tell me if yes, please? Just like
not yet.
Not yet. How about now? Not yet?
No.
Sorry, let me go back. For some weird reason, it didn't let me. Entire screen. Now it lets me. Okay, now we're getting there. There's always some little glitches. How about now?
Yes, very good.
Yay, wonderful, thank you. So as I was saying, this great panel is going to connect advanced computation with ecological and social instances and imperatives. And you will see how the connection is tight and really promising. And my role perhaps today is to set the tone, talking about design imperatives in social and environmental crisis. Afterwards, I'll listen to my co-panelists, which is going to be super interesting for me. As Vernelle said, my last exhibition was Broken Nature. It was actually the 22nd Triennale di Milano before coming to MOMA. And it was an exhibition that was very, very dear to me because not only was it a great exercise of thinking about the concept of restorative design, which in my mind and in the mind of my co-curators, Ala Tanir, Laura Mairan, and Erika Petrillo, was the idea that one can be responsible, sustainable, just, and have a very strong moral compass and still not do without the aesthetic pleasure and ingenuity of great design. But also, it was a particularly important exhibition because it allowed us curators to understand what we can do in order to really deliver a message that will stay with the visitors after they leave. The Triennale di Milano was based on the idea that there are so many different threads that connect us humans to the rest of nature, and some of them we have fraught and some we have severed altogether, but some we can still repair. And we wanted to make sure that the visitors that came to the exhibition, usually citizens, because in Milan, citizens really love design, we wanted them to leave with a sense of long time. That's very important because if we want to do something about the future, we need to be able to think beyond the 3 or 4 generations that are physiologically possible. So number one, a sense of long time. Number two, a sense of the interconnectedness of the systems that we live in. And we wanted citizens to understand that the environmental crisis is connected to the economic crisis, to the crisis of democracy, to racial issues, and to all kinds of disparities all over the world. You cannot really disassociate. And as a third goal, we wanted everyone that came to the exhibition to leave with a sense of what they could do in their everyday life to have a more restorative attitude. You see here an example of how we would try to explain long time, with these images of change by NASA that are available for everyone in the public domain. Then we had examples of actual restoration and reparation, with this trellis, for instance, that is 3D printed in ceramics and then dumped into the ocean with some pieces of corals seeded onto it so that in decades to come, it will hopefully replenish the coral reef in Australia. And then also we showed examples of how designers can actually teach communities or help communities replenish and restore the threads that were broken in their own community. This beautiful example you might know about is from Atelier Luma in Arles, where Jan Boelen and a great team of other researchers has created a sort of fab lab, a biofab lab, in a way. One of the byproducts of our pollution are the algae that are proliferating all over the world. This lab teaches communities all over over the world to take the excess algae, transform them into bioplastics, and then use them to 3D print vessels or objects from their own material culture in this beautiful circle that transforms pollution into actual new products that are connected to the tradition. Systems, the thinking, this was the second part. But the third part that was very important was to let everybody leave with a sense of what they could do. There were very practical examples. There were objects that were biodegradable, recyclable, reusable, upcyclable. But what was important for us was to give a sense of the need for empathy. That was maybe the first tool we wanted everyone to have. And I'm showing that tool by showing you a picture by Laura Aguilar, a wonderful photographer from Los Angeles. Unfortunately, she died a few years ago, who had many different bodies of work, but this series of self-portraits in nature in which she would put her beautiful body and say that she could connect to boulders, in a way, take everything to the next level. And what was beautiful about Broken Nature is that it succeeded in this making a direct rapport, direct relationship with our public. These are the kids in 2019 that were doing Fridays for the Future, having strikes from school on Fridays following Greta Thunberg diktats. And they would actually meet in the exhibition, and then they would start marching from there. And that to me was one of the biggest achievements. And it was pursued via design objects. So how design can help us be better explainers, curators as activists, designers as activists or as explainers. I don't believe that the role of a curator is to tell people what's good and what's bad, but rather to stimulate people's critical thinking so that they can take care of themselves in life, in a life that is kind of constellated by design. Vernelle also mentioned design emergency. When it comes to imperatives, design emergency is a great project. Alice Rawsthorne, great design critic, great friend, and I started it in April of last year while we were locked, she in London, I in New York, and I was watching Fat Joe, the hip hop artist, every night doing his own Instagram lives. Told Alice, let's do Instagram lives ourselves to prove to the world the importance of design in these situations, in these emergency situations. And so we started by interviewing, for instance, Alisa Eckert, who's one of the duo of illustrators from the Center for Disease Control in Atlanta that designed the image of the coronavirus. The coronavirus looks like the background. It's kind of a grayish blob with some dots around the circle. And Alisa and Dan Higgins made it into the Hellraiser deep sea water mine with the red S protein that we all have come to understand and fear. Other examples that we showed were, for instance, that haunting front page from the New York Times the day that the US reached 100,000, which seems so far away right now, also in terms of figure, but it was the first time in the New York Times history that there were no images whatsoever on the front page, only names of the people that died. So we covered all forms of design. We covered also anesthesiologists and other doctors that devised split ventilators, and on the right-hand side, the designers from BBDO, a big agency in New Zealand that devised what Alice and I thought was the best awareness campaign regarding the spread of COVID. We even then started thinking of the rest of our history. It's been now a year and a half, the pandemic is still with us. Probably the virus will stay with us for decades to come, and there's a whole world to deal with. And as we said before, all emergencies are connected. So Alice and I started thinking of other emergencies and long-time projects, such as you might have heard about the Great Green Wall of Africa, a wall of greenery planted by all the different countries at the southern edge of the Sahel Desert, going from the Atlantic Ocean all the way to the Indian Ocean, a gigantic endeavor that required not only money and funding, but also diplomacy and the will of the people that live there, but also will of the people all over the world. Now that the Amazon is being depleted, maybe Africa can do something about the balance in the world. We also started talking about architects that have ad hoc community-based or locally anyway based ideas on how to build, from Vinu Daniel in the state of Kerala in India that follows both Laurie Baker's and Mahatma Gandhi's diktat that one builds with whatever is available locally, and if it's waste, you build with waste, or Xu Tiantian and DNA in the Songyang Valley in China, doing what they call architectural acupuncture by building just what the community needs. All the way, for instance, also to the work of Neri Oxman. Neri is one of the latest exhibition that I organized at MOMA, and maybe she is one of the examples of biology and advanced computation coming together in a way that could help us build in a different way in the future. Of course, I'm not the only one doing this work, and neither is Neri nor are the designers that I showed you. There's a whole cohort, an army of us, starting from Forma Fantasma, a duo of designers, Italians, and studied in the Netherlands, and Mariana might know them, and now they're back in Italy. This is an exhibition they did at the Serpentine in London that was all devoted to the timber and lumber industry, showing the underbelly of the industry and the implications of designing with timber and lumber to the destinies of the world. Forma Fantasma had also provided one of the commissions from Broken Nature, showing, as they always do, these impeccably designed objects that are almost like Trojan horses to deliver understanding about some of the most dystopian and dangerous systems on Earth. In this case, it's about electronic waste. Those pieces of furniture are made using only electronic waste, and they are a way to attract visitors so that they then are hit over their head with these interviews from activists and other actors that are part of that are trying to dismantle the toxic system of the electronic waste recycling and disposal all over the world. So activism of that kind happens also with artists. Right now at the Venice Architecture Biennale is an installation that I was also part of that was spearheaded by Olafur Eliasson and Studio Other Spaces about a possible future assembly and interspecies United Nations of sorts. And just at the United Nations this past September, Superflex and TBA 21 installed this amazing video of siphonophores. Siphonophores are deep sea creatures that come up to the surface about twice a year to feed. And they were projected over the wall of the UN during the United Nations General Assembly in Florence in September. When we did Broken Nature, we also organized a series of podcasts that show all the different aspects, all the different ways in which design imperatives can become part of our lives. There was an episode about corn. It took its steps from one of the objects in Broken Nature that was done using the husks of legacy heritage corn reintroduced in Mexico. But Corn Feeding a Lie talked about the connection and the relationship between Mexico and the United States. Should Secondhand Be Our First Choice talked about the implications and the responsibilities of fashion towards when it comes to the environmental imbalance today. Then we had, well, we need to become less human to survive the climate crisis, about how the human body is adapting, changing, or will have to change to withstand the climate crisis. And last but not least, who is a river? About the personhood and the rights that have been given to nature by magistrates, especially in Latin America, especially in Colombia. And that leads me to bring together computation and nature in the figure, for instance, of the indigenous scientist, and also in the coming together of art, engineering, anthropology, and indigenous wisdom. Another conversation that happened in April of last year in the course of the Broken Nature exhibition was between me and Eduardo Con, a great anthropologist that talked about the sentience of forests, how forests actually are people, just like the rivers that were implicated before, and talked about the changing of the idea of Vitruvian man in architecture in order to accommodate these new wisdoms that are also what are preached by Ursula Biemann, who is a Swiss artist that has been working, invited by the indigenous people of Ecuador and Colombia, has been working with several tribes to, for instance, establish an indigenous university. In her work, Forest Law from 2014, together with the architect Paolo Tavares, they advanced the idea of the indigenous scientist, who in the future will bring together the kind of Western science that obliterated indigenous wisdom when the colonial powers happened, and connect it with these wisdoms that are more prepared to deal with the destinies of the world than we are today. And I would like to end by quoting a white male mathematician from the beginning of the century that said something that I remember all the time, and that can apply to the way we should behave in the future in order to get away from our past self-centeredness. Discounting the interests of future people is ethically indefensible and arises merely from the weakness of imagination. This is Frank Ramsey, 1928. Today, we might just say it's not only other people, but also other species and other planets, other beings in the universe. But let's always remember it arises merely from the weakness of imagination, and design, if anything, is imagination at work at its best. Thank you very much. And I'm now going to give the word to my next panelists.
Wonderful. Thank you so much, Paola. Really provoking sort of prompts for this conversation. So let me share my screen. And folks can see my screen, right? Yes. Great. So thank you to the conference organizers for the invitation. I really appreciate this year's theme, realignments toward critical computation, and especially this prompt of realignment during this past year plus, I think is of interest, but also maybe the past 400 years for those that are familiar with sort of the prompt and framing of over 400 years since the slave trade landing on the American continent. The idea of crisis that Paula was raising is an important prompt. Some of you may know that the NAACP's magazine is called The Crisis, and that magazine has been in print since 1910. And so this prompt of time is something I wanted to introduce in this presentation as we explore together the idea of what does collaboration, participation, and empowerment mean in a frame of crisis, and when and how is that happening. So I'm going to show things from the past, not so much from the current or the future, and how that has connected with the theme of computation and design. And so we have to think about innovation and ingenuity, computation and thinking and imagination, right? And so this is an image of what sort of a white European imagination was able to produce and to have tremendous impact on the earth and its people, right? And so this is a drawing, this is something that's drawn and designed and engineered and sort of evaluated through the terms of computation, right? So along with the boats that would have carried people from Africa to the Americas in slavery would have come along with all of these wonderful computations. This is a manifest, right? The accounting of the people that were turned into cargo. There were other accountings for insurance and mitigating risk, from everything from weather events to biological plagues that were with great ingenuity sort of considered and designed. And so we have to think about, there's this imagination that has been able to radically transform the world, and what are some other imaginations that were able to transform the world. One last thing I'll note here, the idea of categorizing people by color that were described as copper, black, and yellow, right? And noted as such. And so we have to also think about innovation, sort of, again, long stretches of time. We have all of our advanced technologies today, but if we look back, the role that technologies and computation have had, that there have been previous modes of innovation. One that has become now very much in the collective consciousness is the framing of redlining. This is a HOLC map, Homeowners Loan Corporation map of Indianapolis, the city that I happen to be from. And people know by now, right, the prompt of redlining, kind of spatially differentiating spaces. And this is sort of the image and kind of the thing that people attach to. But it's important to remember that behind the map was the computation, right? So these are the kind of the tables and the work and all the effort of enumerating and calculating how people, their identities, their lives were calculated to create a fiction of imagination, a fiction of risk that radically transform people's lives. And so this is an excerpt of that same redlining map in the accounting, right? The designation of blight, almost solid Negro, right? That is a description, almost solid Negro. What does that even mean, right? So this is a computation. And so, you know, these is sort of a grounding frame that I wanted to offer, but then I wanted to offer a counter story to that, and what I call what you ought to know. And this is an old history from that same redlining map that you saw of Indianapolis. This is work from an organization called the Flanner House. This was a Black organization in Indianapolis operating in that time and frame of racialized, spatialized discrimination in our cities that have affected so many conditions. I'll just read a few prompts from it, but this is this group of Black people operating with how they were going to direct their space. What is it about? About people, their needs, their abilities, then the land they live on. And it goes on to say it's about what people know and don't know and what they ought to know to help make America still greater. So these are people under duress, sort of pushing and challenging, what is it about, right? What is the work? How do we build? What are we doing together? And so this gentleman is my grandfather. His name is Albert Allen Moore. And so he was one of those people working for that organization. And growing up, we heard that, okay, well, he was a farmer. But actually what he was doing is he was doing a lot of computation, actually, and that he ran a large food program, an urban agriculture program in the 1940s and 1950s, where they were providing for food and resource for people in that community to address a lot of issues that they had, such as food access. So through that garden program, families and individuals were given plots of land, and this is land in the city. It doesn't look like it, but it's in an urban area. Access to equipment, seed, canning facilities, and consultations to provide for food for their families. And so they had collectively 600 plots that were together around 100 acres worth of land within the city and able to serve 200 families as a part of that program. And so a part of the logic for doing this work was to think about the people. Again, what is it about people, and finding ways to connect those people socially to their community, to their land, to resource, to the ability to kind of have a positive life and benefit. And so there are many different types of people participating in this program across age, gender, etc. And so what was really wonderful about this organization, again, guided by that frame of what is it about in doing their work, is that they understood that they needed to learn and understand their community and their people. The image on the left is a sociograph where they took the time to go into the neighborhood, which would have then been considered, what do they call it? Almost solid Negro, slum, ghetto, et cetera, et cetera. But they went and talked to people and understood what did people know? What did they not know? Where was their capacity? Where was their strength? Where was their need for support and access? And they actually mapped it out, right? So this is a drawing like, you know, there's no Facebook, there's no LinkedIn. They're understanding their community. And what they were able to do with that was to strategically identify 21 families that they would be able to work with to plan, design, and create a whole new way for how they would build their community. And so they create an initiative called the Fall Creek Homes, which is to build 300 units of self-help housing, construction housing. So again, lots of spreadsheets and tables and calculations for how they would get money, how labor would work, how materials and design were all factored in to create a system whereby people that were designated as being of low value in the society would be able to be able to kind of create and design their space. And so they worked with Hilliard Robinson, who was an African-American architect, prominent African-American architect, probably most known for things like Langston Terrace or public housing, but he actually was also designing this type of housing that was built by Black people for home ownership. And so the families that they connected to were trained in the skills to actually build their homes. They would work on weekends, they would take workshops, and these were all people with no construction experience in building. But they did their first project. They did a pilot home. It took them nearly 6,000 hours to build the one house. But by the time they sort of built this neighborhood out, they got that time down to construct the homes to 2,000 hours. And so they're thinking about all the systems, and they're working against systems. So systems like redlining, systems like predatory lending practices or exclusionary federal policies. But because of their work, they were able to make these homes eligible for FHA mortgages, which it was very, very rare at this time to work against the system for Black people to have access to the systems of finance that white people enjoyed. And so what they were able to do is to build their own neighborhood. And you'll see in the design, Hilliard Robinson's the architect. This is in the early 1950s. So the idea of the customizable home, the idea of different material applications. There's so much ingenuity and work and innovation and imagination coming into this space that is in a complete counter to the work that we all know. So I'm going to share a short video of this really important history that I think everyone ought to know.
A special ceremony in August 1950 marked the beginning of construction by Planner House Homes Incorporated. The first ground was broken by future owner, a disabled war veteran whose home was financed locally by Railroadmen Federal Savings and Loan Association. As a matter of fact, a large part of the residential property in the project area was sold to Planner House Homes Incorporated. Planner House is a red feather agency with a half-century record of helping people help themselves through community projects and fundamental education. As a project in self-help home building, it provided leadership in establishing Planner House Homes, a corporation which furnishes capital voluntarily subscribed by leading citizens to enable families to build their own homes. Each family is chosen on the basis of good health, personal responsibility, family stability, and the ability to work with others. The head of each family puts in a minimum of 20 hours a week on the home building project in which he's participating. When on his work the required number of hours and his house is completed, he obtains a mortgage loan from a local financial institution. His labor provides the equity. The proceeds from the mortgage loan go to Planner House Homes as a payment for the land and material used in construction, thus replenishing the capital and allowing additional projects to be started. Most mortgages are insured by FHA or the Veterans Administration.
So I just wanted to share that because it's like this happened in America in the 1950s, and this is not something that we're told or taught or is understood or is valued, and it's important. There's tons of design, there's tons of ingenuity in this work. So just quickly, I'm almost out of time. You know, this is outlined in red is the area that was designated as a kind of a solid Negro area. Outlined in orange is the public housing, the kind of Tower in the Park style public housing that was built for segregation. They were able to redesign and rebuild this entire community. And what we see as we move forward to today, their community was able to persist. It remains as one of the only affordable and predominantly Black communities in the downtown of Indianapolis, whereas the public housing failed. Much of it was demolished. Other areas saw all of the concerns of urban renewal. So I'm going to zoom by quickly. Oops, sorry. Fast forward to today, these issues still exist. This is a map of another community in Indianapolis where I'm from. Everything in red is vacant. Everything in green is low assessed value. So these conditions, it's not the redlining that existed before, but it still is with us, right? So the past is present. So we've been doing work in Indianapolis, dealing with issues of vacant housing, finding ways to rehabilitate that, vacant land, finding ways to bring it back to life and into service with things like food, with things like community participation, with young people by networking and connecting people, creating places of pride in our communities, but also thinking about the economics, making sure that dollars are recirculating to people that are in and from the communities, making sure that social connections are being made and linked. And finally, that the environmental concern and care is a part of the work. And so this is a project that myself and my family have done with our organization Urban Patch, the Indy Redbud Project. Redbuds are a tree species, flowering tree species native to the eastern US, including Indiana. And we did this project to address these sort of patches of disinvestment, racialized harm, long-term crisis, and see how they translate into space. So we took some of these vacant lots and simply had this idea that we were going to have beautiful redbud trees take care of the land for us for a time until our community was ready for another life as a way of holding the land. And so this was one of the many vacant lots that we were able to implement in this project, kind of in the early stages. And today we see that there's this ability to kind of transform and hold the land and space in a new way. And the final point I'll make is that as a part of this work, it was that social project about the people. So the way we've planted hundreds, getting close to 1,000 of these trees is that people make an agreement to take care of their trees. So long-term residents are agreeing to care for the tree. Newcomers are agreeing to care for the tree, and collectively they're building this network that helps us ask, what is it about? My last statement is just a quote from Joan Tronto that I would offer as a framing for this question of computation through the lens of care. It says, on the most general level, we suggest that caring be viewed as a species activity that includes everything that we do to maintain, continue, and repair our world so that we can live in it as well as possible. So I'll leave it with that and look forward to the rest of the presentation.
Thank you. I guess I'm going next, so I'll share my screen. Thank you very much for that wonderful presentation, because there's a lot about community that comes back into that, and computation from a different point of view than what I will be talking about. But hopefully by the end, I managed to also bring in some community and computation in the same sense. So I would like to talk about challenging construction through the computation and digital fabrication. And I wanted to give you a little bit of a background about myself, even though you've heard this at the beginning of the presentation. But that's because I started recently at TU Delft, so that is in September, and I'm someone that's somewhere at the intersection of architecture and structure, computation and fabrication, and that's purely because of my, let's say, starting out in Delft, but being minted at ETH and during the and within the NCCR. So actually, a lot of the work that I do is rooted in this, in the sense that the research and the projects that I've worked on find themselves at that intersection, and it's always striving to couple good geometrical form to be materially efficient and to use that material effectively, and to see how that can be addressed in construction. This, of course, comes as no surprise on the backdrop of the fact that the construction industry at the moment faces two main challenges. The most pressing one of them is posed by the environment, and I don't need to mention that that it is one of the big contributors to greenhouse gas emissions, somewhere around 40%. But this is also coupled with a projected growth of global population, which kind of poses a conflicting need. One, that we need to reduce our resource consumption on the one side, while at the same time somehow becoming more productive. And productivity is also on its own a problem when we look at the construction industry, and this is usually actually attributed to mainly a lagging behind in digitalization. So the point is actually that what we're facing as a challenge in addressing the problem of the environment is actually digitalization and the environment. So to do that, we need to somehow join forces and develop innovative, sustainable design strategies and building solutions that tackle not only the questions of design, but also fabrication and construction of possibly more efficient structures. Now, usually when we think of computation and digital and digitalization, we think of design very often. And the truth is that when it comes to design, we do have an abundance of computational methods to help both architects and engineers and fabricators, to really come up with these designs. So we have, we can do that in a very artful way, so much so that it has given us the impression that we can design and build absolutely anything we want. Unfortunately, the paradigm that we can build anything we want has to change, and we have to go towards actually building forms that are governed by principles of efficiency, economy, and elegance, so that we can be more effective with our material use and the way we build those structures. So these principles are not new, and they have been the root of the best structural works over the past 2 centuries. And that is usually because in the absence of modern technology or analytical tools, these kind of good forms were something designers and engineers really needed to rely on. And they were usually pushed by very pragmatic needs, such as economical, material, and construction constraints, to be able to do this. These kind of engineers designed, focused on a design process driven by performance, where the minimal needed form was the one that governed what was being built. So there are some wonderful examples of Pierluigi Nervi's work, or Buckminster Fuller, or Eladio Dieste. Now, computation, in this context, there is still computation in the sense that to find these forms, they usually employed form-finding techniques. And these form-finding methods were usually physical ones. The most famous ones are perhaps the ones that every single architect or engineer knows from school, Antoni Gaudi's hanging chain models. More recently, or in the 70s, we have the models done by Fraiotto for the Mannheim Multihalle, for example, which were these physical models that are actually computational models in trying to find the form. And they were also being measured to be able to see how we could design with them. Unfortunately, of course, trying to translate these types of forms from a physical model into a real structure can be really time-consuming, and it's not necessarily always as precise. But this was done at the time where computation, in terms of computers, or what we have today in that kind of a powerful context, did not really exist. But now, of course, we can translate these kind of methods into algorithms and design tools that use the same principles. And they are simple, they are fast, and they can therefore be extremely powerful in those early design stages, to give us the opportunity to have a better starting point. So there's what I really like about this is actually this relationship between having between the physical and the digital. And even though we are moving now towards more the digital, that relationship between the physical and the digital still remains, maybe in a different sense. So what I like to talk about quite a lot in this context is, in the context of digitalization, is construction, and more specifically, the challenges associated with building complex structures, concrete ones in this particular example. And that is because even though we can design more efficient shapes that use very little material, we need to also figure out a way to build those shapes, because otherwise we just translate the problem of material efficiency towards the construction side. Why? Because usually these shapes, if we look at how they are being constructed in reality, we find a technique or a way of doing things that has remained largely unchanged for the better part of a century, if not more. We've become more precise in how we do things, and our processes have become more streamlined. But the bottom line is that these formworks stay the same. They're heavy, they're clunky, they need to be held up by scaffolding. And usually, if we do have special or complex geometries, it means that they are being only used once, which means they turn out into a pile of waste. Now, unsurprisingly, of course, there is a lot of research being done both in academia and in practice on the question of formwork, so on how do we construct things, or how can we cast these types of efficient structures. And these try to address all types of challenges, such as being lightweight, being able to reuse the mold, 3D printing can do almost anything, leaving that in place. And a different kind of approach is to do this using a membrane, so using a flexible formwork, where instead of having the rigid timber mold or foam mold, you use a membrane that is somehow tensioned into shape as a mold. So that could be inflated, held up by splines or cables or rigs or otherwise. In doing so in using such a system, actually, what we do is we manage to move away from needing the heavy scaffolding, so we don't need as heavy foundations, but also using a membrane is a lot lighter than wood, it produces less waste, and it doesn't need as much support. So by focusing on this type of system, we're also a little bit forced to think about the geometries that we need to build, because flexible systems don't also allow you to build whatever geometry you want. Now, in my work, I developed a flexible formwork system that uses 3D knitted textiles as lightweight formworks. Why specifically 3D knitted textiles? Because you can do full 3D shaping, you can have minimal stitching, you can have a sort of branching and complex geometries, you can have channels, pockets, openings, and very specifically tailored material properties, or actually functional grading of that material. So very briefly, how that works is we start with a design, try to fabricate a fitting textile using existing machinery. That textile is then shaped by tensioning using temporary supports, and it's coated with a specifically designed thin cement paste or other coating to give it an initial rigidity, because it's otherwise so soft. So the result is a super lightweight, rigid structure, which can be used as a formwork. Now, there are two sides to this, two challenges. One is, how do we get from the design to the knitting? That means that we need to discretize our design on the one hand to be able to get it into smaller pieces that are fabricatable, and then create the instructions for the machine. Once we do have that textile, the next challenge is, okay, now that we have it, how can we build a structure with this? There are two possible avenues. So on the one hand, textiles are very compact and easy to transport, so they can be brought to the site where they're coated and become the formwork. Or we could do the same on components in a prefabrication site and then transport those lightweight components, assemble them on site, and whichever way you go, this becomes the formwork for the concrete structure. So to test this type of system, there have been quite a few demonstrators at various scales, whether it's nodes, whether it's small bridges or actually testing it at scale. So what I wanted to show you is actually the first project is Nit Candela, which tests this type of system at scale. It was built in 2018 in Mexico City in collaboration with the Zaha Code Group. And it's a shell that is inspired by Felix Candela and built with a cable net and a fabric formwork. And what is particularly special about this geometry is that it's a waffle shell. So it is a thin shell with rib stiffeners in two directions. So in this particular case, we deal with the complexity of geometry, not only globally in terms of double curvature, but also locally in terms of those cavities or rib stiffeners. So very quickly, how that was built was by erecting a temporary frame made out of timber, tensioning a cable net and textile into it. The textile already has these channels and pockets integrated within to guide the cables and also guide inflatables that then create the cavities within the concrete. It is then coated on one side with that specifically designed cement-based coating to give it the initial stiffness. Once that hardens, concrete can be cast normally into onto the formwork. And once that hardens, the frame can be removed and the structure is left in place. The formwork stays within the structure, and it's actually also what you see on the inside of the finished piece. So what is interesting about this is somehow the fabric part of things is that it has a technical side and an aesthetic side. So it's really looking at these two parts. One of them that is seen and one of them that controls the construction process and where that material is placed. So having openings for inserting the cables, having openings for registering those connections, having pockets that inflate at different rates on different sides. Now that textile was fabricated using an industrial knitting machine that looks something like this into four, it was made in 4 large strips that are arguably the world's largest scarf. It could be packed very compactly into vacuum bags. You can see us doing that here, and it weighed very little. And we brought it to the construction site in our suitcases, mainly because we're architects, so we finish the night before we need to leave before the deadline. So on site, those 4 pieces got put together by a local seamstress into one huge piece. Then all of the cables were inserted into this piece manually by us. Those the connection points, so the nodes, were registered and fixed, and then the entire package was taken outside and tensioned around the main poles of the frame. And why I like this image very much is because if you look at it from a construction point of view, it's not only the moment when we could see that this stretched to the right size, but it's also the moment where you can actually see that 50 square meters of double curved surface can be very lightly held up in space. And it would be very hard for me to imagine what this looks like out of an EPS mold or out of timber, or how that would need to be held up. So here you see the coating process. You can see my colleague Lex, who developed the coating for this. And once this is coated on one side, what we're left with is kind of this beautiful Swiss chocolate of a formwork. Now, why I wanted to point out here is that in this particular case, these pockets or these squares that you see are the cavities that are with the material saving cavities within the concrete. But what is particularly interesting about it is that they are all different. And usually with computational design and digital fabrication, we have the paradigm of mass customization, meaning that the machines don't care if they produce 500 times the same piece or if they produce 500 times a different piece. But what we're left with is actually a problem of labeling and on site, making sure that everything goes into the right place. And that becomes where your errors could be, or where your human errors can come in. In this particular case, that intelligence is included directly within the knit. So the degree of inflation and the size of inflation is actually controlled by the knit, by the pockets in the knit, And the only thing that needed to be inserted within it are these inflatable balloons that were all the same size, but produced 500 different types of sizes. Now here you can see the concrete being applied on it normally by very skilled, masterful concrete workers that really managed to render the surface so smooth that I suppose Felix Candela would also be jealous of. So some takeaways about this, because it is important in terms of productivity and in terms of what it might mean for impact of the construction industry, is that the formwork, so just the cable net and textile, but excluding the frame, for 50 square meters cost about $2,500 and weighed about 50 pounds. Now I've translated this from metric, so I hope it's correct. It's more or less. It also took 36 hours to produce that textile versus about 750 hours, what you would normally need with milling or timber or something of the sort. And the entire project took about 3.5 months to complete, which would have been impossible with traditional techniques, because those 750 hours are actually equivalent to about 3 months of work. So here you can see a small video of the finished piece, and you can see that play between the soft textile interior and the hard concrete exterior, and how these come together. So in conclusion from this project, what I wanted it to actually show is that the system has some benefits over traditional approaches, as it's lightweight, it's easy to manufacture, it's highly transportable, it's quick to assemble, and it significantly reduces waste in those terms. And there are several possibilities to use this at scale. Of course, none of these things are actually possible without the appropriate computational tools to enable that fabrication. So if everything I've shown you until now is actually dealing with the construction part, so once we do have that textile, how do we construct? One of the challenges is also, how do we get from the design to the knitting? And we definitely need those types of computational pipelines. And very briefly, why we need those things is because, for example, knitted fabrics are created through interlocking of consecutive loops. And the knitting machine, which is something that you see on the left here, uses instructions in the form of a line by line. Ooh, so that didn't work out. Give me just 1 second to restart. I'm sorry, guys. I wasn't expecting that to happen. So while that restarts, basically what happens is that we need those line-by-line instructions that are actually a little bit of a pixel grid that tells the machine what operation it should do at every point or every needle and every pass. Now, usually that's, oh, here we go. I have it. Let's see if I can. Hopefully this doesn't happen again. I'm really sorry, but we're almost there. There we go. So usually this happens because a knit can be seen as a matrix, and if you want to create a different kind of geometry, so a 3D geometry or a bump, what you'd see is that the backside, the length of the backside of the textile and the length of the front side of that textile are different. But what you can do is to add material locally, and that can be done directly on the machine through this short row kind of shaping, where you have these kind of pixel grids that show you where you can locally add materials because of those units. Now, those types of instructions are usually created in a relatively laborious way, where a technician knows exactly where to place these features to get that 3D geometry or those types of features. We can, of course, imagine what that might look like for primitives, such as spheres or ankles or things like this, or bends. But when we come to construction, there's a, wow, okay. There we go again. So when we come to the construction part of things, what happens is we don't necessarily rely on primitives, and we also don't use those geometries at a small scale. So what we want to do is have an automated way to go from our design to the instructions for the machine. And part of that is very important in terms of computational tools. And I'm trying to restart this again. I'm really sorry this is happening. Because if we do that, so if we do manage to do that, we do overcome also an entire bottleneck in terms of production. And that enables us to really take advantage of, I hope you can see my screen again, and that enables us to take advantage of an infrastructure that exists globally in terms of machines and fabrication. This was a little video of the of how that algorithm of producing the knitted the patterns is there. So we can take that type of development into that existing infrastructure globally. So what I want to very quickly show you is actually a new development, because one of the possibilities of knitting is functional integration. And in this case, a very promising one would be that one related to reinforcement. And this is a collaborative research done also within the NCCR and with my colleague Minu Lee. Now, placing steel reinforcement bars in spatial doubly curved structures is quite time-consuming and laborious. So being able to create this kind of stay-in-place formwork that also acts as reinforcement is very promising, both in terms of taking out the steel reinforcement from the structure and in terms of labor. So some of the experiments on that side are on how these kind of textiles can be equipped with features and special inlay yarns so that they can act as reinforcement, and how we can make sure that they bond better with concrete, but also moving a little bit towards more traditional, well, beyond the surface-like applications of shells, and looking at those possibilities of more traditional elements such as rectangular or I-beams, where those cables or tendons can be threaded through loops and channels and might be directly used in the construction. So here you see an example of a rather traditional section, but where you have a spiraling reinforcement all around, or a particular one where these kind of yellow inlays that you see there are spaced out specifically are at the exact length that they should be, and they can guide traditional reinforcement through. They are also coated with a different resin type coating instead of the concrete, and they are cast. And here you see something that is a little bit less architectural, but it's very promising structurally in this sense. And we also test those. I'm not sharing with you any of the test results, which we also don't have, but it's something that Minu can do. But what I wanted to point out here is that at some point when these were tested, the formwork or that coated textile needed to be removed so that the behavior could be observed behind. And what is interesting to note is not only the surface texture that comes off, but it starts asking these types of questions of reusability, sustainability. How can we use these either in a reusable way? How can we separate materials at the end of life, and so on? So one of the last projects that I wanted to show you in this case is the fact that it's important to go beyond the shell or the prototype phase. And to be able to show this kind of work is, we're doing this with a circular pedestrian bridge, which is being designed to be built in the Netherlands in 2023. It's done together with Rijkswaterstaat and with BASICS, so it's with real contractors and in a real context and permanently. And the design of the bridge is inspired by the structurally by the 3-hinge arch of Robert Maillard. And in this case, though, the structural depth is achieved through the synclastic double curvature of the shell geometry. So this is what the bridge looks like. And of course, because it's in the Netherlands, the soil conditions are a little bit more difficult. So we're trying to use also the deck as a post-tensioning part. Now, the tensioned textile that will be used in this case, we're looking at what kind of materials can be used there in terms of whether they're recycled or more natural materials, the coating and the stiffening as well, the foundation concept so that it's reusable, and what kind of impact it would have on its environment. So the bridge would be used using, will be built using a double knitted textile and tensioned into shape using glass fiber reinforced plastic splines. While we don't have a prototype of that, I'm referring to an older bridge that we've built in the past to kind of show in which direction that this goes, where you see this kind of tensioned splined textile that doesn't need very much support and can actually be turned into a structure. It shows something very important, that you can build lightly without needing all of the support from below. So it means that you can also build efficiently in situations where you need to have an unobstructed passage. So finally, going towards these kind of more traditional sections makes it possible to also come closer to industry. If I started my presentation with saying that we need to talk about how we fabricate, how we design, how we fabricate, and how we construct, I wanted to leave on a note of how I hope to go on now within TU Delft in the next few years with these kind of points. How do we build, actually? So not only how do we design, and who builds those things, and who builds what we design, but also where do we build? Are we building for the Western world, or are we building for the global South? The context in which we build, and the people that build those designs, and more importantly, what do we build and what is important that we build? Because through computation and through digital fabrication, we've come to a point where we can indeed do almost whatever we want, and we've proven that it can be done. But the question is, what should we be doing? So with that, and thank you very much, I would give this back to you. And I'm so sorry for the technical problems. I hope this didn't take too much of the time.
Hi, everybody. Thank you so much for your presentations. They were really thought-provoking and intriguing, and I hope I'm able to connect them with my abstract, zoomed-out thoughts for this evening. Can everybody see my screen?
Yes.
Okay, wonderful. So I will go into questions at the end, but I wanted to share a few thoughts, a few more conceptual thoughts on design imperatives for the social and environmental crisis. And I started thinking about these intertwining crises, as already has been said before by the wonderful speakers, as indivisible and intertwining problems that were described even before the pandemic as a kind of landing on Earth. So I'm talking about the scholarship precisely of Bruno Latour and his 2017 book, Down to Earth, where he claimed that at some point climate change, social inequality, and economic deregulation would land on Earth. Perhaps during the pandemic and today, we are among this landing, and I think that this was evidenced by the talks. In the aftermath of the pandemic, the world of neoliberal governmentality and ethics hopefully seems to be waning, and new forms of practice are allegedly emerging. And hopefully, again, during our state of connected immobility during the past 2 years, for those of us that were privileged to be in that state, we were called to reflect on the fragility of our production processes, which was evident in the third talk, the hubris for ceaseless growth and endless mobility, and finally, our accountability for how we occupy the planet. In many ways and forms, the three profound and thought-provoking presentations that we saw today explore the role of architecture, social dynamics, and environmental thinking within the context of these interconnected global crises: the climate emergency, social inequality, and the depletion of natural resources. In a very broad overview, we witnessed how architecture constructs, distributes, and leverages power, as well as how spaces are shaped by larger political agendas that unequivocally involve questions of race, gender, materiality, and biopolitics. In questioning how we might assume responsibility for architecture's political, social, and ecological and social agency, I would like to offer a few thoughts on the table as a response, particularly relating to the urgency of the climate crisis, and to be more precise, the ways in which we construct narratives to understand, process, and reflect on environmental problems. And I will do this by challenging or discussing, negating the promises that were outlined in this book, Cradle to Cradle, which was a very important and best-selling book published in 2002 by architect William McDonough and chemist Michael Braungart, which in some ways has become a foundation for what we may loosely call the buzzword of sustainable design. My points will outline what I tentatively call the problem of encirclement, the idea of understanding ecology explicitly as a kind of circular reasoning. And I'm referencing this because the idea of circular reasoning not only reflects the logic of the imperative, which has definitely prevailed as an imperative of optimization, but also it is not only an ecological form of reasoning, but a computational form of reasoning at the same time, reflecting on recursive models and loops that regenerate constantly new complex behaviors. So through that, I'm going to bring in these three problems and see how we can think otherwise, how we can deconstruct these fixed narratives, and how the presentations possibly reflects on that kind of deconstruction. So the first problem that I would like to challenge is the idea that waste equals food. And I'm not saying that all circles and all cycles are bad. I think that definitely the ones that, for example, Paola showed with the algae were very wonderful examples. And I have a love-hate relationship with the idea of cycling, but the imperative of cycling has constructed a capitalist model of production and in many ways a compulsive logic of thinking about environmental problems. In this logic, the life and metabolism of living creatures is decoded and replicated via technological instrumentality and directly transposed to industrial and design systems, advocating for a full circle of life with no loss. This simplistic and frankly false sense of holism has been directly applied to building systems and cities under the umbrella of integration. The problem with this widely circulated premise that has been popularized in the field of sustainable design is that architecture is projected as a neutral field with little disciplinary intelligence of its own. The authors of that book considered design as a field to institutionalize common sense. The idea of a world where all resources are recirculated and never wasted, though comforting, defies intricacies present both in environmental sciences as well as in design thinking and computational thinking. Moreover, it dwells on wishful thinking and the idealization of the world as a field where all resources can be endlessly and effortlessly regenerated. What is even more troubling is the belief that natural systems, the life and metabolism of creatures, can be applied with no consequences to artificial systems like production lines, materials, manufacturing, and eventually building systems and cities. This logic is not explicit to ecological thinking, but also circular loop systems as organizational divisions are computational systems, namely recursive models that generate complex behaviors. Therefore, the collision of ecological and computational models demonstrate an ontological problem of creating autonomous personal spaces or protective environmental enclosures around selected and privileged population groups. The second problem that I would like to challenge is the idea of what I call earth holding. And these are a series of popular photographs, just copy and pasted from Google if you write sustainability. The idea of circularity has fostered a wide perception of earth holding, a progeny of earth photographs held gently and affectionately by human hands, as if the earth is a wounded creature that needs our care. This anthropomorphic perception of the earth as an endangered living species that is cute and sentient, as a being that needs to be petted by us humans, its conquerors, is delusional at best, as it positions our species at the center of all pivotal planetary developments. Our perception of the earth as one interconnected world, as an image that promotes unity and balance, is no longer the case. Unilateral strategies for divergent problems, in the ideological belief that the metabolism of the planet can become the foundation for technology, culture, and design, is no longer applicable. And here I'm showing this idea of humans as the ones that are going to repair by geoengineering the earth, which is already nascent in 1960s. This is an excerpt from Progressive Architecture in 1969, where architects are tasked with the role of repairing actively the planet by geoengineering and redistributing natural resources. And I'm showing very quickly these three images to understand changing perceptions of circularity and the earth as reflected in extraordinarily popular images in the web. That this is considered the blue marble, which was a very, 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 very famous photograph, which almost has become the icon of environmental thinking and has been used in The Inconvenient Truth and so many other documentaries and environmental institutes. Reflects this finite reasoning of resources and the idea of circularity in 1972. But already it was not replaced necessarily, but this is another very popular image by the Opta project in 2003, which is the first to map 14 billion pages that make up the network of the web. And it was not only a visualization of network connections, but also a mental model that still depicts things in the world as part of a dynamic continuum. The world is imagined here as a giant assemblage of neural networks exploded into the Milky Way. And more recently, a darker reality, which is, this is not real, it's a visualization of NASA of space debris, but it already just depicts in a very vivid way the amount of waste that we outsource outside even of the breathable atmosphere, or we will projectively outsource outside of the breathable atmosphere. The third problem, which I'm going to speak of relative to this idea of cycling, is what I call the problem of the arrow. And here you see the invention of the recycling logo, which has been so widely popularized and recirculated and reused by corporations. It was designed by a student who was 23 at the time, Gary Anderson, and he created it in 1970 as a submission to an international design conference. But I want to say that the idealization of circularity reveals a deeply rooted problem of deduction of information in environmental representation, which is visualized almost exclusively through the use of arrows. Since the 1960s, the ecologist that you see on the screen, Howard Odum, and his EnerGES, energy systems language, has instrumentalized ecosystems as well as human agency in terms of input and output. This representational language for ecological simulation models that is directly originating from the way that electronic circuits are being represented has become the primary tools for architects to visualize performance and energy flow. Arrows, however legible, remove, nevertheless, a type of drawing agency that is critical to our field. The question is, can alternative notation systems and fields effectively replace arrows, given that arrows point only to the end goal of conversions, but say very little about the process of recycling and cycling itself? Information deduction as a problem in environmental representation was an ongoing anxiety for Chilean biologist Francisco Varela, who argued in his book, The Embodied Mind, following his very famous work on autopieces with Humberto Maturana, that cognitive systems cannot be understood explicitly on the basis of their input and output relationships, but by their operational closure. A system that has operational closure is one in which the results of its processes are those processes themselves. The brain, as Varela argued, uses processes that change themselves while they're operating, and thus we cannot separate such processes from the products that they produce. Similarly, the language of environmental representation reflects a process of interlinked threads, while these threads are trying to develop a relationship with themselves. In the environment, perception is seen as a cognitive process of hypothesis formation, not as a simple prescription or reflection of pre-given information. Since the time of the blue marble that exemplifies the world encircled within its finite resources, we are now in a much darker place, plagued by entangled global crises, as we have seen in all of the presentation. The role of architecture and urbanism within the context of the precarity of life, which is a term I'm borrowing from anthropologist ANAcycle, that is, life without the promise of stability and wholeness, can neither be entirely about restoration nor about the idea of a harmonic past. The dream of geoengineering a better future, as announced, for example, in the Eco-Modernist Manifesto, which was assembled by a number of eco-visionaries of the 20th century, is not only a startling project of human hubris, but also a crumble of ruins of a lost empire, one where humans dominated over non-humans and disavowed differentiated responsibility for environmental degradation by evoking the image of the whole planet. As anthropologist ANAcycle prompts us to think, in our current world, contamination is collaboration. We are contaminated by our encounters. They change who we are as we make way for others. As contamination changes world-making projects, mutual worlds and new directions may emerge. Everyone carries a history of contamination. Purity is not an option. One value of keeping precarity in mind is that it makes us remember that changing with circumstances is the stuff of survival. This age that we might tentatively call the multiverse, or as Arturo Escobar coins it, the pluriverse, does not tolerate the separation of humans and non-humans. Rather, it urges the exploration of a shifting web of life and death. In the current, hopefully terminal period of neoliberal capitalism, marked by the climate crisis in alliance with social-political unraveling, we are called to rethink modern humanism and its role in structuring our built world. How can we understand the built environment decentralized from human ego and anthropocentrism that has prevailed without doubt since the Enlightenment? These are some valid lessons that the contested term of the Anthropocene holds for us, namely that attendant ideas of progress, hubris, and freedom have driven current devastation. Humanity must, in this narrative, insist on being humble. To do this, we must look at debris, the waste of our own production processes, understand environmental and social problems in a visceral way via the raw ecologies of our bodies and the understanding that these problems are not simply statistical and abstract. They cannot just be relayed to the management of resources, but they're landed on bodies, to the water we drink and the air we breathe. Waste is potentially also powerful and worthy. It can generate methane, new forms of power, and new economies. It is as much a subject of theoretical analysis as a factual constituent of capitalist production. To write a new history, a counter history to optimized circular economies in material conversions, one needs to see the raw potential of our waste. Only through this confrontation may the ecology of life somehow be useful. We need to investigate, monitor, and document the strangeness of the real and invent in an architecture that is completely devoted to the problems of the real, but not unaware of its uncertainties and complexities. So with that, I thank you and invite all of you for a discussion. I have a lot of questions and comments, and but I don't know if somebody wants to begin. Vernelle, should I just like start with questions, or?
Yeah, you can start.
I just want to thank all of you for your wonderful and thought-provoking presentations. And I think that I'm going to start with a question on the idea of reparation, restoration, replenishment, which was mentioned by Paola, but also in some ways and forms by Justin in his patches of disinvestments and racialized bias and reparation processes. But also I think partially in the work of Mariana also by looking at material forms as as forms of reparation of new ways to build. So I wonder, is there a way that we can think of these types of processes without being more humble and more not using geoengineering and grand master plans, but using other formats of thinking and acting? And if so, what would these forms be and look like?
So you would like us to be more humble. That's what you mean. So no geoengineering, but more.
No, I wouldn't like you to be anything. I want you to be exactly what you are. All of you. And
do you mind if I jump in?
Absolutely.
First of all, Lydia, thank you. Your presentation was really great. And regarding these terms, I think that reparative and reparations was used by Justin with more authority than by me. For me, it was a very interesting decision amongst all the different terms that I could use. But one thing that was interesting in Broken Nature is that there was a whole list of possible points of pressure and ways in which citizens could be more responsible, sustainable, however you want to say it, that ranged from the upcycling and the recycling to the kind of digital exile that has become the normalcy with the pandemic. But that, we're talking about reducing footprints by doing Zoom. That's what we were forced to do before. It was almost like one possible strategy. So there are myriad ways in which we can contribute to just doing things better. Amen.
Yeah, I think the kind of cross-cutting thread of all of what we've shared is this notion of how do we build. And one of Mariana's images, sort of on the ground doing something together, right? Seemingly mundane, but the idea of the hierarchies, the power structures, the sort of resource dynamics that I think people understand need to be rethought and rechallenged are challenging to do, because the paths, the sort of systems are really in place to make us all go back to rote, right? To sort of base ourselves in the norms. But I think in spaces where people are showing that there are broader norms, there are a wider variety of norms that we can accept, incorporate, and adopt as practices is really key. And so I just really appreciated seeing that in Mariana's, especially sort of illustrated in that in some ways what the machine was doing and what the people were doing were somehow together, right? Even though they've been really, really designed to be differentiated in terms of resource, in terms of access, and all of these different things. So I think that idea of like, how do we make things more kind of connected in the plane is where so much of the work is.
Mariana, can I tell you what my favorite part of your presentation was? And you can answer to both questions simultaneously. I love this work. I think it's extraordinary, the kind of research with the fabrics and how it unfolds. My favorite part was where it was like this giant scarf that was packed in the suitcase, and it was carried, and it was reflecting this precarious process of architects hugging their models and going to the exhibition site, and the kind of labor involved, and when it was unfolded and stitched, and it really involved such labor that it reflected how this super streamlined computation process, maybe the question that Justin is asking is interrelated, you can tell us, is that there's an underlayer behind that, which is about precarious labor and somehow contingency that underlines these conditions, no matter how streamlined the algorithm is. And I just wanted to ask you about that, because I that was my favorite part.
All right. No, I'm glad that was part of your favorite part. It's one of my favorite parts too, because it makes you do things, and then you become the constructor, you become part of that value chain, and you become not just a designer, but you get your hands dirty. And we as architects, as designers, as creators love that, because it's a way to indeed hug your work or feel that it's your baby somehow. I would say that we have to step away from that at some point, because the truth is we can't singularly do that, and we cannot control the whole process ourselves. So that's just to have a sort of disclaimer to these kind of things. I think that there is always a contrast indeed between how streamlined an algorithm is and how that ends up in practice. And this is inherent to any sort of construction practice and any sort of building, any sort of going from the digital to the physical realm, wherever it may be. And this doesn't necessarily only have to be in the precariousness of what you've seen of, okay, we make an algorithm, we fabricate something, we go to site, and then we have to do things by hand, but also in the types of tolerances, or in the types of being able to really get to that, or replicating whatever is in the digital world. I don't think there's as much. I think what I like about the project is that it underlines, or it shows indeed this. Who works on this? How do you work on this? How do you apply the material? Is it safe? Is it not safe? In the end, it's lighter, it's easier to work with. It's a lot easier for humans to work with than other materials that are out there. So it does allow to rethink work. And it does allow to really show that you could have actually a very streamlined process of design and fabrication, and that maybe we're not there yet on the very streamlined construction side, but we have to go towards that. And that doesn't necessarily always mean that you have a particularly high-tech answer to it. It can be a little bit of a lower tech, but high-tech informed. Because why I'm saying that is not because I don't believe in the high-tech part. I do believe in the high-tech part. Just to disclaim, but the part is that makes it a little bit more relatable, or makes it possible to include people already from now, or to include already existing skilled labor from now.
It was actually why I wanted to include that example from the 1950s of the connection of community and their labor to the built environment in a very direct way, and showing the clip. And I know the sound is not great, but it's a really old clip. But showing people actually learning the skills and like knowing that there is this process from 6,000 human hours to 2,100 human hours, and what it actually took to do that was beyond the scope of what we normally take responsibility for, right? There was a whole set of systems that they were thinking about, from childcare to health. And, you know, there are all these sort of networks of ideas that need to be understood as connected to the work of building and built environment, that I think for a lot of reasons we've become so separated from that it's a challenge to do work that's truly quote unquote community based, right? This generic word that people throw around, has to accept, if you're going to use the word, you then have to accept all of it, right? Somehow as being a part of the resource and responsibility system for our work as designers.
I was also really struck, Justin, when you showed the manifests of these boats. That was such an extraordinary sight, and how they were categorizing and creating these, hyper logistic machine to where people were actually units within a system. And I was thinking, if you, what your thoughts are, and I'm sure we all have thoughts on that. You probably heard of this billionaire, the dormless, the windows.
Oh yeah,
dorm, right?
oh yeah.
I mean, isn't that a parallel?
We're going down the rabbit hole.
Isn't that a parallel? Like, if you put these two, the kind of
Yeah.
plan of that building, and ostensibly the students are part of another kind of manifest that is, so what has changed, and how can we use our agency to change the logic of the machine logic that generates these kinds of systems is a critical question for our discipline, because it's not different. It's just insane that it's not different.
Can I just to, it's not a machine logic. This is pure human logic. This is pure inequality, or this is pure privilege. This is something else. This is not machine, or this particular example is not machine.
Of course, it's the wrong. You're absolutely right for pointing this out, because machine logic reads in a very different form and doesn't distinguish or makes hierarchies between, person X and person Y. It just reads every name as we distill that logic within the algorithm. We put it and we inserted it. So it is very much, but there are hierarchies, like it becomes a kind of systematized production system. So it is a kind of hierarchy. So I don't know, Justin, if you want to, and Paola, you seem to have thoughts on that as well.
Yeah, I mean,
well, how can you not have thoughts? No, go ahead, Justin, please.
Yeah, I'll just say the reason I started is really to kind of the point that Paola was sharing kind of at the end of her talk about, like, this idea of the imagination. And like really understanding the power of it. And so that drawing of the ship, like that took imagination, really. Right. And I agree with Mariana, it's not about machine or rationality or any of that. It's actually about pure unencumbered imagination. And so what is our counter to that? Right. And how does it become as invested, as empowered, as impactful as this sort of horrible imagination that we are all still like living with, whether regardless of your demographic and background and history and heritage, we are actually all still living with this unimaginable, horrible imagination.
See, I respectfully and lovingly disagree. I think that that is mere visualization. Imagination would be different, would be an envisioning of a better or worse future. I mean, it would be, there would be something more. Um, Sometimes I wonder, I did a project a few years ago that was called Design and Violence, because I was trying to understand the manifestations of violence in contemporary society through design objects. And it was about contemporary, so I didn't use the slave ships design, but it was in my mind. I did use redlining, as redlining was one of the case studies. Well, if that dorm had happened at that time, it would have been in, right? Because that dorm is a symbol of arrogance. It's not even evil, it's ignorance and arrogance. It's thinking that the other, not half, but the other 99.99999% can live in cubicles like cattle, right? And it's okay. And if you see the picture of the two, Warren Buffett and the 92-year-old amateur architect next to each other, it's like, oh my God. I mean, Warren Buffett should not go around with him, because we've always thought of him relatively well, and now it's like ruining him for everyone. But no, to me, really, I think that imagination is what can propel us forward, in some cases for, in evil ways, but it is always a leap, right? And instead, that to me is just a visualization of how to fit as many humans as possible within a dorm or a ship. And in the case of the ship, I mean, I kind of like shuddered a little bit, because the ship was leading to a particular destiny that was much worse than UCSB students, even though they should be treated better anyway. But yeah, ignorance and arrogance are just what is keeping up from everything, from designing a better extinction, from living better, from just like everything.
Yeah, I agree there.
So I'll ask a question that Justin posed. Because we are running out of time, and I see Vernelle opening her camera. So I hope that this is the last question, because Justin posed it in an email, and I think it's a very interesting one. And it's a very simple one, but a very complex one at the same time. How would design education ethics practice and projects shift if we prioritized using our intelligence, creativity, and resources to care for our people, places, and planet?
Big little question.
Well, yes, it's yours. You were asking about the architectural education or all education?
I would say design education, architecture and design education.
Well, I don't know if it's feasible at all, but I found that Indigenous University example really interesting. Now, you might object to the fact that it's Ursula Beeman, she's a Swiss artist. Is it more of, white Western people colonizing? But actually, she was brought in as an artist to help the Indigenous people find a way to create a bridge, right? So that's just one possible idea.
Sharing knowledge and practice.
Vernelle, you showed up. It means we have to wrap it up.
I wish this could go on forever. This was such a great discussion. You're a wonderful bunch altogether. Very, very fun and exciting. Lydia, thank you so much for framing all of these discussions. Mariana, Justin, Paola, thank you absolutely so much for sharing your time with us. Okay,
thank you. Bye.
Perspectives. Thank you.
Take care, everybody.
Thanks, everyone.
You're welcome.
Bye.
So we took this keynote as far as we could because it was so good. So we are going to start with the next paper session, redefining spatial tectonics, material transformations. Just give us a